did talk about a binomial theorem to any power. And from the very beginning, I would say 3.5 months ago, we reviewed something very basic from algebra, 3 terms. Now, obviously, I'm expecting my students to remember this because we know that this expansion will have n plus 1 terms. However, on this test, I saw something like this. I also saw this. Please look in your, or squared. I saw this. At least several of you did this. What's wrong with this? Yes, I know we all make mistakes in a stressful situation, like a test. I make mistakes when I try to fit in something in the last 2 minutes of the class, rushing through. I know. But what is wrong with this? Because this is really basic. And we've been doing this for 3.5 months. That was the very first thing we did, a plus b to the 2nd power, or a minus b to the 2nd power. So can anyone tell us what is wrong with this? Anyone?
That's only 2 terms.
It has to be 3. So this is 1 plus 2 sine x plus sine squared this. And this is 1 plus 2 cosine 2x plus cosine squared 2x. So please look in your, assuming you received your test back 3 or 4 or 5 times already. I'm sorry, I was getting an error message. My apologies. It was telling me, error, you cannot send, error, you cannot send, and I will click and click and click, and I should have not done that. So please look at your notes or solutions from the test, and please make a note of this. Okay, any questions, anything you'd like to start with, anything? You choose, please. Any problem from the test or otherwise? And again, I still have this here. Anyone would like to start and choose a problem to work on? Anything from the test or anything?
Can you do question number 2 from the test?
What was it? Please remind me, sorry.
I think it was tangent 195 degrees.
Excellent. Perfect pick. Now, obviously, we know the tangent has a period of what?
Pi?
Yes. So then I know that, first of all, the tangent of 180 plus 15 is the same with tangent 195. But because the period is 180, all I need to know or find is tangent 15. Tangent pi plus 15, because this is its period, is the same with tangent 15. Here we have 2 options. Option 1, to find tangent of 30 degrees over 2 with a half angle, which is 15. And option number 2, and there is an option number 3, but let's say 45 degrees minus 30 degrees, and use the difference. I can use 60 minus 45, which is also 15, but still a difference, the same formula. It doesn't matter which one you use. You have to get the same answer. So if we choose, for example, the difference, remember the formula, or the identity to be exact, tangent alpha minus beta equals tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. Tangent alpha is easy because it's tangent 45. Anyone remembers tangent 45? It's the only angle for which sine and cosine are identical. So then tangent must be
Is it 1?
exactly. Thank you very much. Now remember I said don't bother memorizing. You have the formulas if you want, you can use your notes. But in general, don't bother memorizing this. What's the point? Tangent 30 is very easy. Is sine 30, which I know is 1/2, over cosine 30, which I know is the square root of 3 over 2. So the answer is 1 over the square root of 3 after you flip. And you rationalize the square root of 3 over 3. Again, there is no point in memorizing because you must know sine 30 and you must know cosine 30. So from here, I jump here and I put in the formula. 1 minus this over 1 plus the same thing. Find the least common denominator, simplify the denominator, and this is it. Yes, if you want to rationalize it, you have to be careful not to make this mistake again, right? Because I have 3 minus the square root of 3 times 3 times this times 3 minus the square root of 3. So this is 3 minus the square root of 3 squared. I have to have 3 terms. So I'm going to continue on the next page. So 9 minus 2 times the first times the second plus the second term squared. This is a different formula. This is a plus b times a minus b, which is 9 minus 3. First term squared minus the second term squared. So then I have 12 minus 6 the square root of 3 divided by 6. And I can simplify. Remember, the key is one term in the denominator, you can separate it. So 12 divided by 6 is 2, 6 divided by 6 is 1, and this is it. As I mentioned before, plug in the graphing calculator and approximate this, and also plug in tangent of 195 to make sure that you are on the right track. Mistakes can occur. I could have rationalized and made an error. But I have this feature, I have the calculator, right? I'm allowed to use it. I'm going to make sure in 5 seconds, 10 seconds that this is correct. So I will plug in 2 minus the square root of 3. See whatever gibberish I get. But I also will plug in tangent, but make sure that I'm in degree mode first. And I plug in tangent of 195. I have to get the identical gibberish. If I don't, something is terribly wrong. I will not just simply put the square root of 3 minus 2 or something. I will double check to make sure that I found it. So the problem says exact. Okay, fine. I found the exact 2 minus the square root of 3, but I will still check. It takes 30 seconds to check. If I don't get the exact same thing, then I'll say, oops. Good. Is this clear? Do you have any questions? Do I need to go back to any step? Everyone, is this okay?
Yes.
Perfect. Would you like to choose the next problem?
What are these type of problems called?
Yeah, so these are the trig functions, right? When you are asked to find sine alpha plus beta, you're given some information. When you're asked to find tangent of 195 or so on and so forth. These are all under trig functions and function values. So also here, so the same type. The trig functions, maybe I should have said here identities more, because I put sine alpha plus beta, cosine alpha plus tangent, and so on and so forth. So maybe it's better to say trig identities. Trig identities, double angle, half angle, sum, difference, double, and half. So this is what I really meant here. So the trig values better in number 7. Anything else from the test that you want to go over, please? Any problem? So look at your notes or solutions and tell me which other problem you would like to work on. Let's use the time efficiently, please.
Rico,
Yes.
can we do
Which one, Sophie?
sine x squared times cosine x squared?
Sine squared, like this.
Yes, ma'am.
Okay, this was also done in the notes.
Well, it was actually on the squared is on the outside of the parentheses, so it'd be sine x squared.
It's exactly the same thing. So let me explain this one more time. Sine x squared is the same with sine squared x. Now, sine x squared is a totally different story. You have to square x and then apply sine to it. But if the power is outside or is touching sine, is the same thing. This power is not for x. This power is for the function. So writing like this or writing like this is the same thing. So here we have to remember two very simple formulas. 1 minus cosine 2x over 2, and this one 1 plus cosine 2x over 2. These are very, very important identities. Where do they come from? From cosine twice alpha. That's how we develop them together, step by step. Good, so now when I multiply them, I get this times this. So it's over 4, and when I multiply them, I use the formula or the identity or the product rule, the a minus b times a plus b, right? A minus b times a plus b is a squared minus b squared. When I square cosine, not its argument. I separate this and I get 1/4 minus 1/4. Cosine squared, I have to apply the same formula again. But this is of double angle, so I have to have double angle here. 1, 2. 2, 4. So I have to write 1 plus cosine 4x divided by 2. And it's done. So 1 over 4 minus 1 over 8 minus 1 over 8 cosine 4x. Let's see how we got this. Remember, there are two terms at the top. I separate into 1/2. 1/2 times negative 1/4 is this. And 1/2 in front of cosine times 1 over 4 is this. All I have to do is perform this. So it's 2 minus 1. So it's 1 over 8 minus 1 over 8 cosine 4x. That's why I record all this. That's why I post the notes in the hope that my students will review and redo these before they do anything else. If you don't, you will always have less knowledge than you should. That's always my hope. Good. Anything else you would like to continue with? Any questions here? Anyone? Good. So let's choose another problem, test or otherwise. Please choose. Let's use time efficiently, please.
Can we do
Yes.
the summation from question number 10?
Yes, when you remind me, it was from k equals,
K equals 1 to limit at n,
oh,
limits n,
yes,
and
so,
then 2 times 1/5 to the k minus 1.
very good. So this is a geometric series. So all you have to write is 2, 1 minus the common ratio to the nth power over 1 minus 1/5. This is the formula. You don't have to do anything. This is exactly what you needed. K minus 1, this is A1, and this is R. So let me write the formula one more time. K equals 1 through n from A1, which is the first term, times the common ratio to n minus 1. This equals A1, 1 minus R, the common ratio to n over 1 minus R. This is the formula. Everything was ready for you. You didn't have to expand, you didn't have to factor out anything, nothing. Everything was ready. So 5 minus 1 is 4. I'll continue on the next page. So we have 2, and then we have, this is 4 minus, so 5 minus 1, which is 4. I'll flip it into 5/4. And then I have, with brackets, 1 minus 1/5 to the n power, and close the bracket. Simplify here, and it's done. 5/2, 1 minus 1/5 to the nth power, and this is it. So again, this is a geometric series. You had the by comparison, just by looking at what we are given and comparing to the general form, this must be the first term, 2. This must be, because it's exactly, of course I meant to write k here. So it's exactly, the common ratio is exactly at the power, is not k or k plus 1, so I have to make some molding in there. Nothing. Everything is the same. I identify the common ratio to be 1/5, and then I put 1/5, 1 minus 1/5 to the nth power. The denominator is 1 minus the common ratio to power 1. I perform this, I flip, and that's it. 2 lines. Any questions?
Professor, I have a
Yes,
question.
yes, please.
How did you get the on the second page?
Oh,
How did you get the 5/4?
so the denominator is 4/5. This is 4/5, and I have to flip it because it's in the denominator.
Oh, okay.
Better?
Yes, ma'am. Thank you.
Perfect. Next question. Is this okay, everyone? Is this okay? Any questions? Okay, let's choose the next one. Anything.